So it's amazing that people are going to be stationed around the moon,
right,
certain amount of days. And also, Japan is providing the pressurized rover for the moon.
The LTV, yeah. Mm-hmm. Yeah, we're very excited. We get to work with our JAXA counterparts and our Canadian Space Agency counterparts in ESA and Mohammed bin Rashid Space Center counterparts very frequently. We were speaking earlier about JAXA being here.
Yes.
We have one of our representatives from Gateway Deep Space Logistics that spent a year in Japan working with JAXA. So
that's great.
We do cross-train and
we
value our input from all of our international partners.
As I came down, I actually forgot that we had this great graphic up here that I can kind of talk to. But I'm the Cargo Integration Manager for our Deep Space Logistics project. That's part of the Artemis program that we have. And so I'll tell you a little bit about Artemis, a little bit about Gateway, and then Deep Space Logistics and how they fit together. Artemis, it's our effort to go back to the moon with international partners and to stay there long term for scientific research, especially focused like at the South Pole where we can find water, and water is a really good resource because you can drink it, you can split it and get oxygen and hydrogen. That's fuel for spacecraft. So water is very valuable in space. Artemis is composed of several different components. The Space Launch System launches the Orion capsule. The crew will take that. Starting on Artemis 4, they would go to this Gateway space station depicted here. The image over there is a little more current. The configuration kind of changes as concepts mature. But Gateway gives us a place to support those landings on the moon. It gives us a place to have crew there in a permanent orbit. It gives us a place to resupply the landers. As the crew gets here, they'll meet up at Gateway with a lunar lander that would be either SpaceX provided or Blue Origin provided, and take that down to the surface. The small space station here around the moon gives us a place to resupply that lander and extend the missions of the crew. It also gives the crew a place to do scientific research that's, we call it deep space, but the focus is really that it's outside the Earth's magnetic sphere. Once you get outside, like the space station in orbit now is inside that protective sphere. Once you get out to the moon, it's a much more harsh environment for radiation and cosmic particles and those type things, which are harder on the human body and harder on all the equipment. So that's kind of a quick overview of what Artemis is. I touched on Gateway, this crewed outpost, very small compared to ISS.
Yeah, we like to say ISS is more of like an apartment condo complex, and Gateway is more of like a condo. So
yeah, so small. And then at Gateway, our local team, the Deep Space Logistics team, supplies this logistics module. So the rest of the modules are permanent and will stay there, but the logistics module just comes for each Artemis missions and delivers cargo. I put out some cargo bags over here. We deliver cargo. And it will stay there and act as kind of a pantry closet. So a lot of different activities going on there. But at the end of the mission, we'll dispose of the logistics module, and it will likely go into like a heliocentric orbit around the sun and just kind of orbit there. But the cargo that we focus on, and my job is to focus on our cargo capacities and the interfaces, the systems we'll use to deliver the cargo. Most of it goes up in three forms. Cargo bags, a bunch of sizes, all kind of built off this single unit here. We have half bags, a single bag. This is a double bag. We have triples all the way up to about a 13.0 bag. So, and they each nest within each other for that kind of modularity. But so passive cargo and cargo bags. We have a very standardized hard shell system for science experiments. That's been used on ISS for years. You can change these out easily. They have standard interfaces for power and data and thermal. Gateway and Artemis uses a slightly different interface than ISS, but the same concept. And the inside of this can be repackaged for whatever purpose the science team needs it for, microgravity research, cell research, on ISS, there are plant growth experiments, all kinds of things on those. So those are two major types of cargo that go up on the inside of the module. We also carry cargo on the outside of the module, exposed to the vacuum of space.
You can see a little better on this one over here if you guys want to look at that.
Does it have some external?
I think so.
Yeah. External payloads. And that's also a very standardized interface where this can be reconfigured for whatever the science instrument needs, and it'll get standard power and data type interfaces for that. And the cool thing is, once the logistics module docks, the Canadian-built robotic arm will grapple this and move it over to some permanent location on Gateway. These little boxes each represent different locations for a payload. And on Gateway, the payloads are focused on, some of them want to look into deep space away from the sun, and some of them want to look at the sun and study the sun. So those are two big areas of focus. Artemis mission, logistics will launch in that time frame. And we need to launch about a week before, it takes about a week for the logistics module to get there, but we would probably go out at least a month before the Artemis mission.
Are you using Vulcan?
So our first provider is SpaceX, so it would be a Falcon Heavy with this Dragon XL logistics module. Our contract allows us to bring on additional providers in the future. Like ISS has 3 providers now, SpaceX, Northrop Grumman, and Sierra Space, all can provide cargo delivery, unmanned cargo delivery to ISS. So we hope to have additional providers in the future.
In terms of sustainability, if there are waste produced, like just any sort of waste produced on the ISS, how do you guys, I guess, is it like brought back to Earth, or like is there like a more sophisticated way of, I guess, compressor or like getting rid of it?
There's a lot of discussion about that, like compressing things, reusing things, repurposing products. On ISS, critical items that we want back, like science samples and things, tend to come back on Dragon capsule. Things that we're going to dispose of come back in the Cygnus module, and that just burns up in orbit. So those are the 2 major paths out of ISS. Sierra will launch the Dream Chaser in the future, and it's a winged vehicle that would land on the runway out here. It would be able to return those critical items.
I see. Okay.
But I like your theme there of what do you do with all the stuff you produce?
Yes,
because it's, getting into space is expensive, and you want to squeeze every bit of use you have. And we have a lot of people that look at things like converting trash to gas. That's an experiment that goes on. I think it's called Trash to Gas. And there are 3D printers. We keep doing research on what you can use for feedstock for 3D printers. Some of the packaging foam, you don't see it, but you have to cushion some of the things in here, and we've looked at using the foam as feedstock for 3D printers. That didn't work out too well, but we're continuing to look for things like that.
Got it. Oh.
Makes my heart happy to hear that question answered, because I'm working on a feature piece about what we're doing with all the trash that we're
I
taking
love
away.
that.
So, hopefully there'll be more media about that coming soon. You're any questions?
Because I'm actually working on a documentary with my friends about sustainability.
Amazing.
So
We'll
connect about that. Yeah.
I'll give you one more bit. This is just my speculation that a friend and I had the other day. So the crew, they wear their clothes for a bit, and then they throw them away. There's not like an easy way to wash clothes. Or they throw them away. And we were wondering, how could you lengthen the life of the clothes? And we were talking about cleaning processes. And I wondered, what if you exposed them to the vacuum of space? Because if you exposed my shirt to space, you would boil off moisture and maybe some other, oily products, and likely kill microbes. And I don't mean kind of hang them out the window.
Like what we do in Asia.
Right.
Yeah.
But if you could have them in a compartment, I'm way out on a limb here. If you could have them in a compartment and expose that to vacuum, I'm very curious. I think you could refresh your clothes.
Yeah.
Wow, that's
Because it kills all the bacteria, you get rid
It
of
does.
moisture.
It should. And if we're in
there's a tinge
space,
of sun, you get,
yeah.
Or how about the plates for the food?
Kind of clothesline.
Plates.
I don't know.
There's really good videos online about the crew eating food. There are not a lot of plates.
There's not plates,
because
all right.
you-
A tube. Yeah.
Yeah, it's tubes, it's packages,
Yeah.
and you don't set stuff down so much, so you don't set the food on,
Right,
on
right.
something. There's
We got some big
videos.
thinkers here in Deep Space Logistics working on those things. It's awesome.
Yeah.
Love that.
But if there's a moon base, I hope there's a way to enjoy food on the plate.
Yeah, you know, there are PhD scientists that study food, and they're so passionate about delivering the food, the crew, like food that they'll really like, and they will certainly be looking at that.
Yeah, 'cause it's-
they work it so hard just for ISS, and hopefully in the lunar environment we could have a, you know,
Instead of
a nicer
tube and then
environment,
cans.
I recently heard the newest development is like spaghetti, but it's like in a tube, and you just like suck it, and that's it.
Yeah, I mean,
or something like that.
it comes in a lot of forms.
I've seen a ramen that
They have ramen
Yeah.
now. Oh my god.
Yeah.
Okay, that's great.
They have a lot of little pouches, and it'll be dried out, but
Yeah.
they'll insert and inject it with water and then heat it up. And
Yeah.
you eat it. It's surprising. They open stuff up and it drifts around a little bit, but they'll eat it. They don't just suck it only out of a tube. You know, they'll eat it. They eat a lot of tortillas and wrap stuff in tortillas. Yeah, bread doesn't keep well.
Wouldn't that be
so they-
messy though? Like, do they wrap it in space or is it already pre-wrapped?
They will
They
prepare
do?
the food in orbit. They'll start with just a plain tortilla and add stuff to it.
Yep. This is not logistical. This is taste related. Do astronauts experience the flavor of food differently? Because if you're in a pressurized airplane at 8,000 feet, it's very different than at sea level. So
It is. The blood moves into their head, you know, you're without gravity pulling it down.
Yeah.
So they have a feeling of being congested and their sense of smell is deteriorated. So they lose a lot of flavor, and they apparently really like spicy stuff because you can still taste that. So hot sauces are really, really popular.
I believe they recently grew chili peppers or something like that, and
They
they were
did,
throwing those.
Yeah.
I hate to even say this because I think y'all are going to go to the plant lab and you're not able to.
no, not today.
Really cool in there. Lots of little microgreens, peppers, tomatoes. It's fun. And this building is pretty gray and austere, and you go in there and you see plants and life, and it's exciting. And it made me think how impactful that is to the crew too, because they're in
Yeah.
the ultimate gray, you know, metallic
Right.
environment. And
Is it going to be
plants.
changed on the gateway interior design? So it won't be gray or mechanical?
You know, sadly, Gateway is very small and will probably be it'll probably be less accommodating for the crew. It's going to be, yeah, Right.
They're not going to be there for like throughout the year.
that's right. The mission durations, I think, are like 15 to 30 days.
Per year?
They actually plant on the space station, like fruits and vegetables, I guess. They actually eat it on the space station?
They have. It took a while before, you know, the food scientists got comfortable with them eating the food, but they've eaten some. It's not like a major source of calories or diet. It's an experiment. But the intent is, you know, to be able to grow food wherever you're going, particularly something like microgreens where you might get a nutrient that you don't get so well in canned food or packaged food. So, but it's hard to really create a calorie source because, you know, that would take a lot of space.
So what is the capacity of Gateway, or what is it expected to be?
Crew-wise, it would be, it's kind of limited by Orion, so you would have 4 crew with typically 2 going down to the surface and 2 staying on Gateway, or at some time in the future, maybe all 4 will go down to the surface.
Oh.
And now with, you know, you mentioned that the, you know, logistics module will be expendable and everything like that. If there are experiments that need to be brought back, would they have to be brought back on Orion? Or?
Orion's the only way back for now, but that's a big bottleneck that, you know, needs attention. How do we get more stuff back? Because we want, you know, more moon rocks as much as anything. So.
Can you talk about how these are made?
Yeah, it's kind of a good story here. These have been around for a long time since, and over time we have this high school program called Hunch. The H stands for high school. I don't remember the rest of the acronym, but they build and develop stuff for NASA and fly stuff, and they build these bags. You know, the material's been chosen kind of historically because it's flame resistant and, you know, doesn't off gas and things like that. But the high school teams actually build them for us now.
So they actually make them.
They make them, yes, and fly them.
Will they be able to touch things?
Yeah, you can touch any of these things here. Hunch also builds lockers for us sometimes to install gear into. This is a Hunch built sleeping bag for the
And it's
crew.
very comfortable.